Hello everyone, welcome today to our video for the add-on stabilization feature, how you can test the add-on stabilization for SIPROTEC 5 relay. For the people who didn't attend our last webinar, today I'm going to do a practical session with the relay settings with a live demonstration for the add-on stabilization feature. So first of all, let us talk about the add-on stabilization. The add-on stabilization is a very important feature just to add more security to the Siemens relay differential protection to avoid the operation in case if we have a heavy external fault leads to ACT saturation. The function will do that it will block the differential protection for a time duration which is called add-on stabilization delay, and after this duration elapsed, the relay will release the function again. The main target of this to add more. This is from here we got the word add-on stabilization to add more security, to add more transient blocking for the function of the differential to avoid the operation in case of a heavy external fault happen at one side of the CT, and the CT saturation happen at one side of the transformer side. So in the settings itself, then you will go to the differential protection, transformer differential protection, IDIF. Here you will find the operate characteristic for the normal differential protection, and at the end, you will find the external fault detection, which related to the add-on stabilization. We have here the threshold add-on stabilization 2.5, which means that the relay will start to activate the add-on stabilization feature or start to activate the add-on stabilization blocking once the restraint current increase 2.5 of the I nominal. The duration will be around 2 seconds, sorry, and the cross block time add-on stabilization will be also 2 seconds. Here, the blocking for each phase, for example, if I have a CT saturation on L1 or I have external fault on L1, so L1 will be blocked for 2 seconds, and it will cause an external block, or I can call it cross block, for the other phases for 2 seconds as well. This settings is just a random setting. It's not final setting of any transformer. This is as well the default setting of our transformer relay settings from Omicron Academy. So what I need to identify exactly what is the relay characteristic, and I need to get more details about the differential protection. So in the settings tab, or I can go to the home tab, and from the home tab I will go to the settings itself, and I will go to transformer primary to get details of the transformer. So my transformer is 160 MVA, 231 kV, isolated star with a vector group 0. This is, I can write it down. Then I will go to transformer secondary, general 118, and the voltage level is 115.5, and it's a grounded star 0 as well. Then I will go again to the settings, and I will go to tertiary because my transformer is 3 windings. So I have 42 MVA, and the rated voltage is 10.5, and it's isolated delta 5. What else I need? I need to get the data of the differential protection itself. This is, we can get it from this here under IDEF. I will get the data of the operating characteristic, and here as well I will go to the IDEF unrestrained, which is the unrestrained differential or second stage, which is 6I nominal, and the operate time is delay is 0. Then I have an OCC file I created. I have here, we follow also Omicron Ohm's law. In the Omicron Ohm's law, I need to identify the object, I need to identify the hardware configuration, and I need to identify as well the module. This module is related to the normal differential, which we are not going to talk about it today, but the second module from here, from the BOS module, I have the test add-on stabilization. I had add-on stabilization for phase 1, for phase 2, for phase 3. Now I will just double click of the 7UT. Then I will get more detail about the RIU. This file we already shared it with the people who attend our latest webinar. I will put it here with in the description of this video to have an access for the people who didn't attend, but I will delete the differential. I will keep only the add-on stabilization. So settings, I will enter the data here manually, the power system, the general, and the primary side, and the secondary side as well. So I will enter the data of the transformer itself from the transformer side, general rated value, as we got it from the Dixie. So I will enter the data here just manually. So my rated value here, my S rated is 160 MVA. Then I have here 2 differential function. The one differential with the regular differential, everything is automated, and the second one is the add-on stabilization. Just to go in details for the add-on stabilization, which is our concern today, I will just double click on it. I will see here that protected object is transformer, and I have the data of my transformer, which is primary, secondary, tertiary, three-phase winding, 231 kilo volt, 115.5 kilovolt, 10.5 kilovolt, 160 MVA, 118 MVA, 42 MVA, star 0 D5, no, yes, and definitely it will be no for the delta because we don't have start point for the delta. CT ratio, I will enter the CT ratio is 400, 600, 240, 2400. So I will get the data of the CT from the DXC itself. The protection device, this is very important tab. You need to understand everything. First of all, the bias calculation will be maximum, I primary, I secondary. This is you can get it from the relay manual itself. No combined characteristic, you need to keep it unticked. This is for Siemens, and you need to keep it ticked for rest of the relay like REX and like RET 670 from ABB. For more details, there is another video. We are explaining what does it mean, the combined characteristic. The test max, this time duration should be at least the add-on stabilization delay plus 100 millisecond. So if you have 5, make it 5.1. If you have 6, make it 6.1. And if you have, for example, 1 second, make it 1.1. So the add-on stabilization delay plus 100 millisecond for tolerance. The time delay, make it 250 millisecond, which is a time delay between two injection points. So it means the CMC will wait for 250 milliseconds between every two injection to ensure that the relay return back to its normal state. I differential, make it 0. I differential greater, make it 0. This is to have infinite line, because if you define here I differential equal to double 0, if you define, sorry, for example, if you define I differential greater equal to I differential unrestrained, it means that the characteristic here will be chopped at 6. But this is not the case for the add-on stabilization. So what we need, I need the line to be extended for infinity. So I will keep the I differential equal to I differential greater equal to 0. Relative tolerance, this is from the relay manual. T differential, this is for stage 1 and stage 2, and this should be equal to the add-on stabilization delay. Zero sequence elimination, this is normal. Like any differential element, you need to eliminate the zero sequence component from the test universe. So you will choose the option IL minus minus I0, IL minus I0. The reference winding, it's normal, the primary because it's a star, and also this is for SIPROTEC 5. Then I will go to the characteristic definition. In the characteristic definition, I have the start point here is 2.5. So I have a vertical line and I have a line, another line. This vertical line will start at 2.5 and it will end at a certain point. But I need to understand exactly what is the slope of this line. As per the relay manual, the slope of this line for the add-on stabilization characteristic is the 30%, or in another word, it's equal to slope 1. Let's go back here. Slope 1, how much? Slope 1 is equal to 30% or 0.3. So the slope of the add-on stabilization characteristic will be equal to slope number 1. And another important point, if I have a point which is here lower than slope number 1, the external fault detection alarm will be there, and the relay will block the differential for 2 seconds or for the add-on stabilization delay. Once the point is reached above or become higher than slope number 1, the relay will block for 2 seconds, then it will reset the alarm. So this is very important to understand the add-on stabilization, that the slope of the add-on stabilization characteristic is equal to slope number 1. So if I have bias current is 2.5, so I need to get the vertical value. This is very normal. Y equal mx. Y will equal to mx, which m is a slope of 0.3, and this line is passing through the origin, so there will be no constant value. Y will be equal to m multiplied by x. X is 2.5 and y equal 0.3 multiplied by 2.5, so the y coordinate will be 0.75. Then I will have the first point. I need another point on the line to define it, so I will just choose, in case of I have the last bias current is 20. So what will happen? It's normal. 20 multiplied by 0.3, it will be 6. So I will have here 2.5 and 0.75, and here the second point will be 20 with the 6 current, 6 I bias. Then I will press OK. OK. Then I will go here to the add-on stabilization. This is the characteristic, but you need to ensure, since if you have in the test object, you have two you have two differential elements, first for the differential, second for the Addon stabilization. You need to come here and ensure this, right click, make set active function. Since it is active, you don't need to make it again. But for example, if you are going here to the normal differential, you will see the differential here is active. If it is in blue, it means it is active. If it is not, it's like that, it's uncolored, it means it's inactive. So for the add-on stabilization, this will be active function since I have two differential. And if for each module, I need to define what are what is the function, what is the differential function is active for it. This is another important point for the people who is dealing regularly with the X-ray. You have this feature, you need to add more functions and inside the RAIO block, and then you can define which one is active, which one is not active. Press OK. Then I need to go to the General tab. In order to activate the external fault detection, what I need to simulate a heavy external fault at the beginning, or regular or a normal load but with a higher current. So I need to go to the pre-fault tab, tick here, and I will say that I will have a huge current, which 6I nominal, which is greater than the value of 2.5. And here I will say later on what is related to 5. So I need to say 6I nominal for a duration 0.05. Let's go back here. Why? I have here the current is 5 instead of 2.5. Since we have in the setting the threshold of the add-on stabilization is 2.5, why here in the graph it's shown at a 5? And why this current, this line in a different color? For the no combined characteristic, to avoid the unwanted trip for the healthy phases, we are extended the regular the normal slope with another line with a double slope. So I have here slope of 30. I will draw another line with a slope 60, and then I will sum both slopes, and you will see that every intersection point will be duplicated. So it will be 2.5, this will be 5. This is the feature of the no combined characteristic. For more details, we have a different video describing what is the no combined characteristic for a differential current. This finally, to summarize it, that it's this function or this feature in the test universe to avoid the tripping of the healthy phases if we have a phase selective relay like RET 670. So the pre-fault, I will define the fault current. So here now it's have a 5, I will have this 6, and I have a pre-fault would be very fast with almost 25 milliseconds. Another thing that I will take feedback from the relay as an external fault detect. So I connected now to binary input number 3, but why it is 0? The characteristic of the differential, normal differential characteristic is here, it's a blocking, and here it is tripping, right? Okay, but for the external fault detection, it's the reverse. Here, the external fault detect will be activated, and here, the external fault detect will be resetted. So I have here 1, and I have here 0. But the differential, normal differential, I have here the differential trip is 0, and the differential trip here is 1. So what I need, I will simulate external fault detect with the pre-fault condition, so I will activate it to 1. Then I will start searching with the search line, so it will be here 1, 1, 1, 1 till it reaches to the line, then it will go to 0. So the relay will understand, this universe will understand where the line went, where is the slope line, where the trigger logic condition of the external fault detect is changed from 1 to 0. Then for the search, you need to be very careful. You can't search here because there is no characteristic. You need to start with a line bigger than the add-on stabilization threshold. Then I will start. You can see the line is changing. And once it is red, it means that it is in the tripping area. Once it is become to non-highlight, it means that it's in the untripping area like that. Then you see this is the line. And the duration, in the general tab, you will see the duration of each fault is higher than the add-on stabilization characteristic with 2 seconds. This is for IL1, for L1E fault. And by the way, the no combined characteristic effect will appear only in the phase to ground fault. It will not appear in the face to face. So do you expect that if I go to the face to face fault, I will find this is instead of 5, I will find it at 2.5 because there will be no effect for the add-on stabilization. There will be no effect, sorry, for the new combined characteristic. For the time sake, I will stop this one. Then I will go here. I will go to double phase, for example, L1, L2. You can see it started from 2.5. Then I will start. Just to do something else to confirm that the add-on stabilization feature is working fine, and this is related to the external fault blocking. I will just track and I will try to get something from the relay with using our IED Scout software. This is also a very important tool. You can get the settings of the relay, and you can get also, sorry, the IEC 61850 stuff from the relay, like GUS, like MMS client server module. So I will try to get the details, and I will show you that the function is activated or not while I'm simulating the external fault detect. So I will just go to, once it is loading, it's going very smooth, and I'm waiting just for the function block to be loading from the IED Scout. And I think now everything is going very, very smooth with the slope characteristic. Let's continue this while our IED Scout is loading the the CID file of the relay. Now we are testing at 7.5 of the IPIAS. You can see here also the current slope is here. This is two phase L1, L2, and also it appear here in L1, L2, and the phase shift is 180 degree. This is because our system is stable. It's loading our IED Scout. We're almost done. This is testing. Now we are testing at 10.5. You can see you can extend as long as you want, and there will be no effect for the unrestrained because the line is extended. So this is a tricky point. And as you can see here, this is a line which we call it the 45-degree line, or the ideal fault line, or the maximum torque characteristic. This is very, very important to understand. I can't simulate any fault above this line. All faults should be here because electrically that we don't have a fault with a fault current higher than the infeed. So this is very important point you need to understand. And this is the line which we can call it the ideal fault line, or the maximum torque angle. Then I will just go to good. Then here I will just say external fault detect. This is the quality. This is true, you can see. So once I'm simulating any fault here, true it means it is 1, false it means it is 0. So you can see the external fault cross block is activated. So it means there is an external fault happening. Then I will give you the other one, which is the external fault. So this is the external fault of the red phase, and this is the external fault of, for example, L1, L2, and this is for the cross block. This is for the goose if I'm trying to monitor the goose from the relay itself using our IED Scout. Feel free to contact us if you have any inquiry about the IED Scout. This part we didn't cover in our webinar, but it's just a tool you can help us to monitor the relay itself. I will record another video how to test the external fault detect and the add-on stabilization feature with our system-based system-based testing solution, which we call it relay sim test. And I hope you like the video, and thanks a lot. And feel free to contact us in case if you have any inquiry. Thanks a lot for your time. My greetings, Ahmed Abdul Wahab.